good for the recording? There you go.
Thank you. Sorry, I was on 2 different computers.
Oh, you're good. All right, guys, still copying. So you're doing A, B, C, and E, and then we're going to flash back. Okay, for people who just came in, you might want to get your phone out maybe and take a picture of the screen because I'm going to be putting it back. We're doing A, B, C, and E. So we were copying them down. Maybe just take a picture of it. And then I'm going to put the main screen on where you'll have the graph and the table and the stuff you need to do these. A, B, C, and E. All right, so last call. Make sure you have a picture. I'm about to change it back to the main screen, or you have these written down. We're going to be working on A, B, C, and E. Okay, here we are. So this is now the information that you would need to complete that. So we are going to give you guys 15 minutes for a 4-part free response. So that would be accurate to what you'll be seeing in May. By the way, I did get some confirmation. It's not official, but it's getting pretty close to official that your AP exam will be on Monday, May 24th. Not official, but it's getting pretty close to being that. Monday, May 24th.
Is there like a requirement or anything? I'm not sure if like, because I know for languages they have to be in person. I wasn't sure if that's the same for math.
That I don't know. I know the proposal on that day is to do it in person. If you are completely against that, which I'm sure some people will be, I will look into what the alternatives are. All right, we got 7:13 on the clock, so I will stay quiet until 7:28. Okay, treat it as a free response. Justify stuff, rate your answers out with sentences. If it's an integral, rate the integral in your answer and all that good stuff. We will talk in 15. Ready, go.
Mr. Baker, I can't see part of the graph because the thing is in the way. Oh, well, it's gone now.
It's blinking on and off, yeah. I don't know how to make that go away, truthfully.
Okay.
I don't, I still to this day don't know what this is. Please move a window away from the shared application. What does that even mean?
I don't think anyone knows.
It's normally like the participants bar, or if you have like the chat up, that's what it normally is.
Okay. Yeah, I don't know. It looks like it's just going to be blinking on and off, guys. Oop, hit the wrong one. Okay, we ready to discuss or do we need more time? That was 15 minutes. Hopefully close to ready. Okay, first one said slope of the tangent line for f at x equals 1. Slope of the tangent line for f. Doesn't even ask for a tangent line, just slope of the tangent line. So for 1, we just want f prime of x, and then we're going to plug in 1. So what are we talking about here for f? F is this function here. So we need to take the derivative of it. So what do we got? Sine's going to go to, we're doing a trig derivative, right? So trig prime stuff prime would be trig prime stuff. What's stuff prime, anybody?
Pi.
Yeah, it's just pi, right? So if it was 3x, it would be 3 pi x, it's pi. So there's the derivative of our first one, plus, how do we do a natural log derivative? Natural log derivative is stuff prime over stuff. Stuff prime here would be -1 over 2 minus x. And into that derivative, we are putting in 1. So f prime of 1 is equal to pi cosine of pi, if we put in 1 for x, plus, that's 2 minus 1 is 1. So in reality, this is -1 or plus a -1, however you want to write it. All right. What do we know? Cosine of pi is -1. So if that is -1, the answer to this first one, messy as it is negative pi minus 1. So don't be afraid if you get messy answers. It happens. Any questions on part A? Okay, takes us to part B. Let K be the function defined by, let's write this out. So for B, we've got K of X is equal to H of f of x plus 2. Find K prime of 1. Find K prime of 1. So let's find K prime first off. Okay, so we've got a composite. To take the derivative of a composite, it's the same deal as a trig derivative. So this would be trig prime, so H prime, trig prime, stuff times stuff prime. What would stuff prime be? F prime of x. Are there any questions on that derivative? If all these derivatives and all these rules are lining up for you guys, we're just about rounding the bend here, I think, to being ready for May. So now into this, you want to plug in, what did it say? Was it 1? 1. So K prime of 1 is equal to, and then we're going to see what we look up here. This is H prime of f of 1 plus 2 times f prime of 1. Okay, so we need f of 1. We have a graph for that. So this is going to be annoying for a second, but we want to go up here to f and put in 1, see what we get. If we put 1 in, that's going to be sine of pi. Sine of pi is 0. If I put 1 in here, that's natural log of 1, also 0. So f of 1 is going to be 0. So now that's h prime. We'll put the whole thing in here. We'll call that 0 plus 2 times. Okay, f prime of 1. Remember, in part A, what did we find? F prime of 1, right? That's the answer to the question, right? So we don't need to do anything there. That's just times, what do we got there? Negative pi minus 1. Okay, so now this becomes h prime of 2 times negative pi minus 1. Okay, how do we find things about h? H is the graph. H prime of 2. 2 lands on this line. H prime would be the slope of that line. The slope of that line is down 1 over 3. It's negative 1/3 times negative pi minus 1. You can distribute if you want, but I would just stop right there and you've got full credit. And you should always finish your answer with what they were looking for. K prime of 1 is equal to. Does that make sense? Do we have questions? Okay. All right. What do we got next? We got C, evaluate -5 to -1 g prime of x dx. All right. So what do we know about G? G is the table. So my first thing here would be that that should just give me G of -1 minus G of -5, right? Integrate G prime, we get G and plug in your bounds. And then all I'm doing is I think it's as easy as this looks now. Just go up to the table and grab these values. G of -1 is 1, I think, trying to read through that yellow box. G of -5 is 10. Did you guys get -9? I think that's it. Nothing there. Easy, nothing to it. All right, part D, we said we're going to skip maybe forever. I don't even know if we're going to go into that. That's not much. That's just crazy math gibberish. If they ask you that in part D of one of your questions, whatever. That's not a big idea in calculus. That lesson's big and messy and confusing and over the internet. That's not the battle we're trying to pick right now. So we got to do one more, and that is part E. Okay, not bad here. Let's see if we understand what you're saying. Fewest number of horizontal tangents for G of X. Fewest horizontal tangents. So here's how we're going to figure that out. A horizontal tangent occurs whenever the original graph turns, right? A horizontal tangent occurs whenever the original graph turns. So with that being said, if we look at the original graph data, that's just these first two columns. Just kind of say to yourself what's happening, or if you want, kind of use your hand and go up and down with it. But if -5, here's -5, it's at 10, we'll say. And then at -4, we've gone down to 5. And then at -3, we're at 2. And then when we're at -2, I'm back up to 3. So I know that a turn had to have occurred there, right? It went from down to above it. So that has to be a horizontal tangent somewhere in there. And then we don't know exactly where. We just know, well, it had to happen, right? And then if we go again, the next value drops back to 1. When I'm at -1, now I'm back down to here. So that means that had a turn again. Now I'm at a second one. And then 0 is at 0. That's still decreasing. So based on that little experiment, I think we can safely say there are at minimum, or how did they phrase it? At what are the fewest number of horizontal tangents is 2, because G of X changes from decreasing to increasing and increasing to decreasing once a piece, or something to that effect. And I think you'd have credit. That's not too much of a question there, I don't think. What do you guys think? Does that, for the most part, make sense? Checks out. Any questions on anything we did? Any questions for me in general involving calculus or whatever?
Mr. Baker,
Yes.
can you turn the paper over to the left so I can look at the horizontal tangent notes? Yeah. Wait.
So I was just saying that a horizontal tangent has to occur at some sort of turn. And then I just kind of plotted some points to see what was happening. And based on the points they give me, I'm not 100% where the turns happen, but I know that they are happening based on the points they're giving me. Somewhere in those intervals, there's turns. So we were able to map out roughly where two of them would be at.
Okay, thank you.
Sure. Anything else? All right, guys. So some of you are back at school today for the first time, so I'm not trying to keep you here all night. I figured do one free response and we'll call it a day for today. Tomorrow, I'm going to have a hard time making it. We got to go to a meeting and I have to do a couple things. So I'm going to cancel tomorrow and we will meet up on Thursday and pick up with another free response there. So enjoy your day tomorrow. Nothing to worry about for calculus. And I will see you guys on Thursday evening.
Thanks, Mr. Baker.
You're welcome.
Have a
See-
wonderful
Thank you,
night.
Mr. Baker.
Thank you.
You're welcome. See you guys. Have a good night.
Thank you.
Mr. Baker,